Alright, that is enough theory for a while. Let's pull this pod up and let's play some football. Let's check our trunks out. Show interface trunk. I did just connect ports 10 on each switch with a crossover cable, so I didn't have to do anything. We know they're in dynamic desirable, so a trunk has formed. If I have 3 ports on each side, which I do involved in this Bulldogs, how many are in blocking mode right now? When I run show spanning VLAN 1 right now, and I've done a write erase from earlier labs, so the other VLANs are gone. Which ports or how many ports are going to be in blocking mode out of the 6? That's a good practice exam question. You can see that all 3 of them on the root bridge are in forwarding mode, as we would expect. Well, let's do a show interface trunk first. And you can see that 2 out of the 3 over here are in blocking mode. So that's what we expected. 2 out of the 6 are in blocking mode. Now, we want to use all of these paths though, and that's why we're going to create an ether channel. So let's do it on switch 1 first. You know what some people will do, and nothing wrong with this, it might actually be a good idea, is they'll go to one switch and put one port in the ether channel, and then go to the other switch and put another one port in the ether channel, and just keep going back and forth. I like to configure one side all at once. And I'm not going to use the interface range command, but I could. Okay, you see I'm on the interface. I'm on interface fast 10. And I've got the channel group and channel protocol options here. Now let's see what I get for channel protocol here. And there are the 2 that we've been talking about for a while, LACP and PAGP. I'm not going to use either one of those though. I'm going to use the channel group option. Here's where you see, first off, a number. You have to give the channel group a number. And that's going to have to match between ports. So if I go over if I configure this side to all be in channel group 1, and I go to the other switch and I put all channel group 3, I'm not going to get a trunk. You do actually have to type the word mode. And then we get our choices, and again, we got to be very clear for the exam, you know, active, auto, desirable, passive, which protocol it is and exactly what it means. We went over that on the board or from the study guide. So what I'm going to do is just put the word on there, and we actually have no other options. That's what we need to pick. So it's channel group 1 mode on, and you'll get a little message there that says creating a port channel, interface port channel 1, and you will also get those 2 messages. This is what I like doing about it on the live equipment. You're going to get a message that says, yes, you just made port channel 1. Again, that's the representation of the ether channel. And you'll notice then we got a message that said this interface has gone up, and this line protocol, that's off the screen a bit, has actually gone up. So that all looks pretty good to me. Before we continue, let's take a look at show config here, and you'll see at the very top, interface port channel 1, this is where you'll always find your logical interfaces anyway. You know, your loopback interfaces always appear at the top of the config, and your port channel is as well. So we've configured a port channel, and I'm going to show you all kinds of show and verify commands here when we're done. But I want to go ahead and finish this. Oh, actually, one more thing I wanted to show you. You can actually use show interface to look at the port channel. And notice it says, and I love that, hardware is ether channel. Hardware is ether channel, so it's got to be physically up, even though it's a logical interface, we didn't have to open it. And line protocol is up. So we're looking for the same old thing there. That's what we want to see. So let's go to interface fast 011. And we'll just do the same thing at fast 012. Just one more time, show you those options. Channel group number, go with 1. You actually have to type the word mode. I know I've said that twice, but when you see mode there, it's like, oh, I'll just type in the mode here. You actually have to type the word mode and then the mode that you want. And we'll go with on right there. So notice we didn't get any messages there about it being created or the line protocol going up because it was already there. And what I want to do right now is show you the effect of this on this side of the trunk. And notice now that where we had individual ports listed, now we have this P01. That's our port channel. That is our ether channel. So we've got desirable 802.1.1Q for trunking. Status is trunking, the native VLAN remains the same. Let's go to show spanning VLAN 1. And a couple of big changes here. Again, we don't see the physical interfaces, we see PO1, but note that cost. That cost is all the way down to 9. And we know that that cost is determined by the speed of the port. And we also know that the lower the cost, that's not good. The faster the port, the lower the cost. Now, I wanted to show you those commands, but I admit I was also stalling a little bit because I wanted you to see this. This is the kind of thing that you bump into out in the field. They tend to leave it out of books, etc. But I wanted you to see this because this is where you have to remain calm. Because it's, it's a little, it'll shake you up, especially the first time you see it. Because you put this in, it's like, oh man, what did I just do? All this is channel misconfig error detected on PO1. And notice this, I think we've mentioned this phrase just once or twice or 100 times so far, error disable. So those ports have now been put into error disabled state. So now it looks like we have an absolute mess. Because now all of our interfaces have gone down, including our port channel. And all of our interfaces, line protocols have all gone down except the port channel. So you're saying, well, Chris, let's see, my physical state of my interfaces, all 4 of them are down, 3 physical, 1 logical. The line protocols are all down, and I have 3 error-disabled ports. Why should I feel good about myself right now? Well, I'm going to tell you that in just a second, I promise you. Because it's not as bad as it looks, but I want you to see that and also see this. A couple features we've talked about in the course, and we'll talk about, port security. You can put a port into error-disabled mode, and that's what we got to watch right there. So if you see this, is down, but always look in the paren. Don't just look at the first part of it because it may be telling you exactly what the problem is. Now, back to the musical question, why is this not all that bad? This is what's going to happen if you're configuring an ether channel the way I did it, all on one side, and then you don't quickly go to the other side and do it because one side is configured for an ether channel, the other side is not. And that's going to bring the ports down every single time. So if you can do it quickly or use the interface range command, let me give you a quick reminder on that. Because this is a good command to know. It's kind of away from the ether channel. I could have used it here, but let's say that you go into a job interview and some jerk like me is sitting there saying, hey, put all 48 of these ports into half duplex mode. Well, you don't want to do this, right? Interface fast 01 duplex half, interface fast 02 duplex half. You do not want to do that. What you want to do is use the interface range command, and you specify a range of interfaces. Now it can be a little tricky at first because you're using hyphens for ranges and also commas to list individual ports. This is actually the only tricky part, I should say that. You got to leave a space in between the numbers when you put a hyphen in here. It's just something you have to get used to. But instead of you having to enter speed duplex, or speed 10 or duplex half 48 times, you just do it once. Because when you do this and you hit enter, notice the prompt changed. Now you're configuring a range of interfaces. Everything I put in here now will be applied to every interface I put in that range. It's pretty cool, huh? So it takes a little practice. If you can practice that on home lab, simulator, whatever you got, that would be a good idea. But don't get thrown. This is what I wanted to show you, and then I promise we'll get back to the other one here. Interface range fast 01 through 12. If you try to enter it like that without a space, I've always loved this caret. Because, yeah, it's invalid input, but you're thinking, well, what's wrong with that? That caret is telling you you're doing just fine all the way up to here. And that's when a light bulb will go off because you'll remember watching this video and you'll say, yeah, I remember you got to leave a space in there. I still trip over it once in a while too, so don't feel badly if you do. Now, let's go take care of those interfaces because if we look right now at show interface trunk, we don't have anything. And that is definitely not good. We need to resolve that. And that's what I've been saying earlier. When you run a show command and there's nothing to look at, it's going to show you a blank space and then drop back to the cursor. But all we need to do, group, is go over here. Actually, let me try the interface range command. We'll step away here. Interface range begins with an R. Then you just put whatever interface type it is. And I'm going to do O10 through 12 channel group, and see it still works. Mode, syntax is exactly the same, on. And it's creating a port channel interface, port channel 1, but that way I only had to type it one time. So, let's see, do we have any kind of trunk over here on this side? We really don't. What do you think the issue is? I've got a not connect here, and I wanted to show you this because this is referring to the physical state of the interface. If you see administratively down, of course, what does that mean? That means it has been shut down manually. You just got to reopen it. Line protocol is down, but don't stop there. Always look at the end of this. Not connect. Well, yeah, I know it's connected. I just connected it. That can also tell you there may be a problem on the other side. What we need to do is go over to switch 1, shut those ports down manually, and then reopen them, the ones that are error disabled. Because notice on this side, they're not error disabled. It just says not connect. But on the other side, error disabled. We got to get rid of that. But the key here is when you see those messages and you're in the middle of an ether channel, just go ahead and finish your config and you'll be fine. Just make sure to check and see if you have any error disabled interfaces. Do you think I can use that interface range command to shut down a bunch of interfaces and then reopen them? That would be cool. Let's check it out. We're all friends here. Interface range fast. Just keep trying to use iOS help here to show you the options. It's 10 through 12. And we'll do a shut there. Let's see if we get the messages. Yep, administratively down. Notice that. I have the window here at the largest font, but every once in a while we'll have a message go off of there. Let's do a no shut and see if we see anything in the resulting messages about our ether channel coming back up. Yeah, interface port channel 1 change state to up. Line protocol interface port channel 1 change state to up. It's looking pretty good right now, huh? Anytime, one more troubleshooting note here. Anytime you're working with something like this and you see a line protocol come up, make sure you stick around for 30, 60, 90 seconds and make sure it stays up, because once in a while you'll get kind of a false message, as I call it. Yeah, that line protocol is up, and then 15 seconds later it drops. Don't declare victory too soon. And now Fast Ethernet 010 is up, line protocol is up, and it's connected. That's what we're looking for. And let's run show interface trunk. Trunk, the past tense of trunk. Yeah, I tranked. What about it? Port channel 1, you see desirable.1q trunking native VLANs. That's all there is to it. So because you remained calm when you saw those messages and said, okay, I'm just going to finish the config and then I'll reset the error disabled interfaces, you're gold. You're all set. Let's make sure. We'll go over to the other side and switch to. Yep, notice it says connected. So that's great. That's just what we wanted. And let's do a show interface trunk. It should be up at every once in a while. I've seen a rare case where the trunk doesn't come back up on one side, and I'll just do a reset if I have to. But it's very rare. And again, we're all set. We're in really good shape. So, again, that port cost has gone all the way down to 9 because we have bundled 3 fast Ethernet interfaces. If we added a 4th, the cost would drop down a little bit more. That is not something you got to memorize, to be blunt. I would know those port costs we talked about earlier, you know, fast Ethernet, gig Ethernet, 10 gig Ethernet, and of course our old friend regular Ethernet. But do not worry about memorizing, okay, if an Ether channel has five trunks in it, you know, what's the cost, that kind of thing. But do be aware that that cost is the one thing that's really going to change. Okay, it's going to go lower as we add more interfaces because we have more bandwidth. Let's bring the live equipment back up because now we're going to wreck it. We're going to wreck it a little bit and see what the effects are. Because we know that we've got that built-in delay if one trunk goes down before the other one can come all the way back up. But let's see what happens if I just go in now and I just shut down a port. And I'm going to shut down port 10 inside the ether channel. Let's see what we got there. Well, we saw the resulting messages about the physical interface that we expected to see. O10 is gone, administratively down, and line protocol on 10 has changed state to down. But what we don't see is anything to do with the ether channel. So let's run our show interface trunk. Well, that's looking pretty good. It's still there. How about show spanning VLAN 1? What do you think the net effect is going to be here? Yeah, that port never came out of forwarding mode, or the ether channel. Note though that the cost did change. The cost changed because right now we have less available bandwidth in the ether channel. So that's the net effect. There is a recalculation as far as the cost goes, but there is no recalculation as far as, okay, you can't send data across this link anymore, we got to go somewhere else. Now what would happen if I shut another one down? Let's see what happens here. Fast Ethernet, change administratively down, and there we go, but we still don't see anything about the port channel itself. So let us run show interface trunk again. We still have our trunk. And we run show spanning VLAN 1, and notice the cost is all the way back up to 19 now, and that is the default cost for a fast Ethernet port, right? We only have one port left in there. And now, of course, if we lost the last one, then we would obviously have no trunk. But what I'll do is reopen them. What do you think is going to happen here when I do a no shut? Am I going to have to reset some ports or something? Anything like that at all, you think? Let's find out. And we see the interface has changed state to up. We ought to see something about some line protocols here shortly. There it is. And again, no message about the port channel. Get out of here. And it's connected. So we're still good there. Excuse me for 1 second while I cut something off. Yes, thank you. Cancel. Ta-da. Now, let's take a look at show spanning VLAN 1. Yeah, it's got to go. And you can see the cost is already up to 9, back down to 9. So that works out really well too. Now, let's run some verify commands. Let's run it. You know what we haven't used yet though? This is wild. Notice that in all of this configuration with ether channels, we haven't actually typed in the word ether channel. Here, I think we're finally going to get to do that. Yeah, we've got quite a few things that we can look at here. There is such a thing as ether channel load balancing. And what we're going to do though is stick with the summary, and we'll look at the detail as well. Because when you look at detail, you're going to be looking at a lot of it. Summary, it's very straightforward stuff. It's got a lot of codes here in the paren, but they're all coded up here. Tells you exactly what it is. You don't have to memorize those. I would not spend time on that. But this one that just says capital S, capital U means it is a layer 2 ether channel, and it is in use. And it's going to show you the ports right here, 10, 11, and 12. Most of the time, that's all you're going to need. But every once in a while, you might run into show ether channel detail. And this one can be pretty cool for troubleshooting too, because part of being a troubleshooter as a network admin, there is some detective work involved. Because sometimes people are just trying to avoid blame, and that deal, it was like that when I got here. The mushroom cloud was here when I got here. And other times they might just not know something, or it could just be wrong. It's not necessarily malicious. But if someone's telling you, well, this ether channel, all these ports have been in this ether channel for, 27 days. Well, I can run show ether channel detail, and check this out. It's going to show me the group state. The reason it keeps referring to L2, this is something we didn't show you in the CCNA studies, but there is such a thing as a layer 3 ether channel. And all you're really doing differently is assigning it an IP address. And you have to have a multi-layer switch for that though, which is why I'm going to mention the layer 3 ether channels and show you one over in the multi-layer switching part of the course. You got 3 ports in it. We know that the max port number is 8. You got 1 port channel. We are not using a protocol, but if we were one of the 2 protocols, you'd see it right here. But also notice that it's got information listed for each port, and what I like about it, it shows you how long each one has been in there. You know, because sometimes, like I said, people just want to avoid trouble maybe a little bit. Human nature, not condemning it, but, you know, we got a job to do. So someone tells you, well, no, that ether channel's been up for, 37 days, and you go in here, it's like, that's funny, they've only been in here for 20 minutes. Then you just go from there. But it's also going to show you here at the bottom the amount of time since the last port was bundled and when the last port was unbundled, how long it's been, that is. So those are some good verify commands, and as I mentioned, there are some other ones here that you may go into even in more advanced studies, maybe when you're going after your IE. But as far as our purposes here, I wouldn't go any further than detail or summary. We could type protocol and just see what happens that we're here. Yeah, just mode on. That's just filtering it down a bit. All right, let's go back to our study guide, and I want to show you a little bit more information about LACP and PAGP. Now, you know you've got the active, auto, desirable, passive bit down. You know you've got to know that. But I've got a couple of other commands here, or verifications for you, that are in the study guide that we didn't do on the live equipment. If you want to verify both your PAGP and LACP neighbors, you can use the show PAGP neighbor and show LACP neighbor commands. And here I created an ether channel with channel group 1 and the desirable option, and you can see all of that down here. That's a pretty rare command. You'll actually use that anyway. You're usually going to use the show ether channel commands. Let's see, and I did mention about the layer 2 ether channels. If you run show ether channel brief and you see that, then actually I do have one in the study guide right now we can take a peek at. It's a layer 3 ether channel, and what you do here, it's going to look much the same. And notice that I put the interfaces in the ether channel with the channel group command, but I also have that no switch port command there. You really got to watch this on the exam, and man, it is so easy to miss. Lab work, job work, I don't care what it is, because on a multi-layer switch, your ports are in L2 mode by default. Okay, so your L2 switch is just your layer 3 switch is acting as a layer 2 switch until you tell it otherwise. And to make a layer 3 ether channel, the first thing you got to do is on the ports that you're putting into the ether channel, enter the no switch port command. That makes it what we call a routed port. It's now an L3 port capable of operating at that layer. And then you'll notice I did the same thing for the port channel. No switch port, and then I was able to put an IP address on it. So it's pretty cool stuff. That, like I said, just an introduction. Actually, for layer 3 ether channels, that's about all you do need to know. But I'll mention it again at that time, that you're using the no switch port command. Use the channel group command as you normally would. And the IP address goes on the port channel, not either or any of the individual ports that are in there. And you must also have IP routing enabled. That's another biggie. Show ether channel brief, and there it is, group state 3. Okay? Stop saying okay. All right, so let's troubleshoot some ether channels. A couple of things to look for, because I have built plenty of them over the years, lab production and in classes. Now, once you get an ether channel up and running, it's like router on a stick. It generally stays that way unless somebody goes in and changes a port setting or something. From my personal experience, here are a couple of things you need to look out for. First off, remember, ports configured to get a dynamic VLAN assignment from VMPFs that we talked about in another part of the course, they cannot remain or become part of an ether channel. So even if you have already put it into an ether channel and it's working fine, and you then change the assignment to be dynamic, that port's going to drop out of the ether channel. You'll get a nice big warning message too. Here's one you really have to watch out for. Very easy to miss, and I was getting a message that I had not quite seen before. And actually, it's funny, I just got an email from a really solid student, and he was asking about this, and I don't know what to tell him. With the Vlan Mask, that's a kind of odd message. Vlan Mask is different. What you're doing, technically, and it's not a term you hear real often, but when you go on and you use the switch port trunk allowed VLAN command, what you're really doing there is masking the VLANs. And again, you may never even hear that term except right here. VLAN mask is different. Just notice what I did here. In one port of the ether channel, I allowed VLANs 10 and 20. On the other, I allowed 100 and 200. and that is going to prevent the ether channel from working correctly. It will not go into error disabled mode. What's going to happen is, first off, you'll get this ether channel cannot bundle message, and it's just going to say, it's not giving you a lot of details until you get to the very end. Is not compatible with. Well, they're not getting along, but they're like people. They could not be incompatible for a lot of reasons. Well, and will be suspended because your Vlan mask is different. Now, what's going to happen here, and what I saw, is that physically the interface stayed up, but logically it went down. And what happened was, when I removed the original command, and did no switchport trunk allowed VLAN 100, 200, then it was fine, except I was still getting these messages. So then I simply went in and changed it to 10 and 20, and then everything was fine just a few seconds later, because you can see the timestamp. I typed it pretty quickly at 2:51 and 15 seconds. I got this message, typed the correct switchport trunk allowed VLAN command in, and all of a sudden it was 2:51:25 and the line came up. And then show interface trunk, show interface port channel 1, verified that everything was fine. That's just kind of thing you got to watch out for. It's so easy to mistype a number, and let's face it, we type a lot of numbers in this business. A couple of other things to look out for: changing a port attribute. I mean, your ports really have to be in line. They have to be synchronized to go in an ether channel. They got to have the same speed. They got to have the same duplex. They got to have the same native VLAN. Just about anything else you can think of. Span. If you're not familiar with this, you will be by the end of the course. This is a way for us to send packets to a network analyzer for analyzation. Ports in an ether channel can be source span ports, which is where we're getting the information from, but not a destination span port, because a destination span port is actually going to have the network analyzer attached to it. So again, ports in an ether channel can be a span port, a source span port, but not a destination one. Also, watch that IP address on your layer 3 ether channels. You put the IP ADDI on the logical representation of the ether channel, the port channel interface, not to the physical interfaces bundled in the ether channel. The rest of the material here on ether channels, I believe I showed you in the guide. You've got show ether channel summary. We took a look at that and the codes as well. And if you want a lot of information, you can run show ether channel detail, and that includes the amount of time that the port has been in the current state, and also how long it's been since the last port has been bundled and unbundled.